Okay guys, so here's some practice on the atomic structure and electromagnetic radiation in Chapter 7, Section 1. The video that I had for you guys was over speed, frequency, and wavelength, and this was the formula that we used up here. Now remember, c is the speed of light. That's always going to be 3 times 10 to the 8th meters per second. This one was lambda, which was wavelength. That's going to need to be in meters. And then the nu, it's actually called nu, that is in U, that is frequency, and that was measured in hertz. So remember, this is meters, that cancels with that meters, that's why you've got to make that conversion. And then hertz is actually, again, cycles per seconds. You could use that unit, but most of the time we just put hertz. And those kind of are the units that are set. So if you want to see the canceling of the units, you could, but just kind of keep track of what's going on here. So if you look at number 1, they want us to find the wavelength. Well, that means we're finding lambda. What's the wavelength of light that has a frequency of 7.66 times 10 to the 14th hertz? So again, we're just looking for one variable because the c is always going to be 3 times 10 to the 8th. So we're looking for the wavelength. That's our unknown. You can put it in there as x if you want. And then our frequency is 7.66 times 10 to the 14th. Okay, so the only main problem with this is you have to understand that you got to deal with some scientific notation. I'm going to work these as if you don't have a graphing calculator, so I'm going to kind of review the scientific notation rules just to make sure you understand. But again, these are multiplied. So if I got to solve for lambda, really all I need to do here is just divide to get rid of that. So I'm going to divide over here. So what I need to remember for my rules is I got to divide the numbers. So in my calculator, I'm going to take 3 divided by 7.66, and then I got to look at significant figures. This one is a constant number, so my significant figures are not based on that number. It's based on this bottom one. So there's 3. So I'm going to say 0.392. Then I got to deal with my exponents. I have 8 on the top, 14 on the bottom. It's 8 minus 14, so that would be a -6 right now. But again, really what I need to do is just make sure that I have correct scientific notation. So I'm going to have to move this to where I have a number between 1 and 10, move it to the right one, that's a -1. It's going to make that exponent -7. So now my answer is going to be 3.92 times 10 to the -7th. And my unit, I was finding wavelength, so again, it's meters. I just kind of keep track of that. So that's how you solve that problem. The next one, I'm finding the frequency, and I have the wavelength. Oh, I should have put has a wavelength. I typed that wrong. I'm trying to do stuff in a hurry here. So I want to find the frequency this time. Again, it's always 3 times 10 to the 8th for the speed of light. My wavelength is 6.3 times 10 to the -10th. And I'm going to find the frequency this time, which is the nu. So again, this is multiplied. I just have to divide here. So I'm solving it exactly the same as I did the last one. I'm just solving for a different variable. So again, divide those numbers out. So 3 divided by 6.3 gives me looks like I need 2 significant figures. So I'm going to say 0.48 times 10 to the, I've got to say 8 minus a -10. So that's going to make that a +10. So this is going to start out as 10 to the 18th. But again, this is not correct scientific notation. So I'm going to move this one to the right. That's a -1. So my final answer is going to be 4.8 times 10 to the 17th. I found frequency. So again, up here, frequency, unit is hertz. And that's number 2. So those were 2 easy ones. Number 3 and 4, I'm just going to solve and kind of show you how you may have different numbers in there that you kind of have to do a step beforehand. Like if you look at this one, the wavelength's in nanometers. So you're just going to have to take care of that before you actually solve it, because if you want to use this formula, the speed of light's in meters per second. So your wavelength has to be in meters for everything to cancel. So if I have 752 nanometers, I'm going to have to make this conversion. You can do this stair step, or you can do this like the dimensional analysis way, which I'm going to show you. If you're doing it stair step, you're going to have to know that stair step. So make sure you kind of review that. But I'm going to go from nanometers to meters. So 1 meter is the base, has 1 times 10 to the 9th Nano is the smaller one. I kind of said this in the notes, but nano is the smaller one, so it's going to be a bigger number, 1 times 10 to the 9th. So that cancels that. Well, really, when I divide this, it's 752 times 10 to the, remember, this is 10 to the 0, so 0 minus 9. That's going to make this a negative 9. But again, to put this in correct scientific notation, I'm going to move that 2 to the left. That's a positive 2. So I'm looking at 7.52 times 10 to the negative 7th meters. And that's what I'm going to plug into my formula. Now I can use this formula up here to solve for what they want me to solve. They want me to find the frequency. So I'm going to say 3 times 10 to the 8th is equal to my new answer in meters. And then I'm finding frequency. So I'm just going to divide. So again, divide here. Get rid of it on this side. You're solving for V. So 7.52 times 10 to the negative 7th here. So take 3 divided by 7.52 and you get 0.3, let's see, we need 3 significant figures, so that's going to be 0.399 if I round correctly. And then I got to figure out my exponent. I've got 8 minus a negative 7. So that's going to be positive 15. So again, I need this in correct scientific notation. So I'm going to move this 1 to the right. That's a negative 1. So my answer will be 3.99 times 10 to the 14th hertz. And that's what you get for that one. And then the last one. You have, it says an FM radio station broadcasts at a frequency of 105.6. That's megahertz. So this one's kind of funny because you need hertz. If you look up above, you need that to be hertz, and it's megahertz. Megahertz, sorry. What is the wavelength? So they want us to find the wavelength. Well, I'm going to kind of show this in the stair step because you guys kind of know kilo. Oops, hang on, pencil messed up here. So you guys kind of know kilo. Well, kilo goes 3 steps down to base. Base would be hertz, because if you think about it, hertz doesn't have any prefix on it. So hertz is the base. Well, kilo, we need to go all the way up to mega. So mega is actually, and this is really hard for me to draw this way, is 3 stairs up from that. So 1, 2, 3. This right here is mega. So we need to go from mega down to base. So that's 1, 2, 3, 4, 5, 6 places to the right to figure out what this is as hertz. So 105.6, I need to go 6 to the right. So 1, 2, 3, 4, 5, 6. That's going to be all zeros. And then if I want to put this in scientific notation, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So 1.056 times 10 to the 8th hertz. So now that I have it in hertz, it will work in my formula. Now I can use the formula up there at the top. It's 3 times 10 to the 8th. Speed of light is equal to, I want to find the wavelength, that is my unknown on this one, times my frequency, which is 1.056 times 10 to the 8th. And then I'm just going to divide here. I'm going to do the same process that I did. So I'm going to divide here. And I'm looking at needing 4 significant figures whenever I divide. So 3 divided by 1.056, I believe is 2.841 with the 4 significant figures. And then if you look at your exponents, that's going to be 0. So you don't really need to do that. So your answer is really just 2.841, and you have that in meters. And that is how you solve those problems. So I've got an assignment attached with this in Moodle for you to try to work out some problems, making sure you understand how to use this formula. So hopefully this was helpful. I'll see you guys later.